Hello, welcome to Introduction to Electronics. In this session, we will review how electricity works, some basic electronic components used in prototypes of products, and how we can use them to create our own prototype. Today's world is powered by electricity. Electricity is briefly defined as the flow of electric charges, but there's so much behind that simple statement. Where do the charges come from? How do we move them? Where do they move to? How does an electric charge cause mechanical motion or make things light up? So many questions. Most of our efforts to obtain usable energy rely on converting energy in the form of mechanical movement, thermal reactions, chemical reactions, and much more just to simply convert it into electricity. We see it being used everywhere. From our houses, turning on the lights, powering components like the air conditioner, the stove, to computers, cell phones, medical instruments, music, everywhere. But before we start making use of it for our prototype, we need to understand a few key concepts that will get us going. Electricity is one side of a coin called electromagnetism. The other side of that coin, as you might have guessed, is magnetism. Both are part of the same thing. Where you see electricity, there's also magnetism. That's why we can use it to power motors to create mechanical force, or we can use the same system by reversing the mechanical motion to obtain electricity. But we can analyze electricity by three components: voltage, current, and resistance. I'm sure you have heard these terms many times before, and basically voltage is the force at which the electric charges travel. Current is the amount of electric charges. You can visualize this as a river where the more water it flows, the higher the current. And resistance would be any obstacle, or as the name says, the resistance of the flow. Many materials like metals allow the flow of electricity easily. We call them conductive materials. Some others have high resistance to the point where electricity won't flow, unless the voltage is incredibly high. Some plastics or rubbers are examples of non-conductive materials, or also called insulators. That is why we use them to cover the conductive materials, preventing the electricity to escape in case it makes contact with another conductive material that we don't want. But as I mentioned, high voltages can break through this resistance, like lightnings traveling through air on a rainy day. So we can categorize electricity in two ways: AC, which stands for alternating current, and DC, direct current. Alternating current changes the direction at which it travels, going back and forth. Direct current maintains its flow constantly in one direction always. Both are necessary and no one is better than the other. AC can travel long distances. That's why we use it to transfer electricity from the power plant to our houses and beyond. It's also easier to generate AC than DC because of the way generators turn, and it's way cheaper to operate. But most devices use DC because of the smooth flow and even voltage. The lights in our houses use AC, and they are turning on and off very rapidly without us noticing. But if you slow it down, you would be able to visualize it. On the other hand, we wouldn't like our devices like computers to be acting like that. Then, DC is better suited for this application. As we study how electricity interacts with different materials, we discovered something that changed our world: semiconductors. So far, we have seen conductive materials and non-conductive, but semiconductors are the breakthrough of the digital age. You don't need to understand the science behind them, but basically semiconductors act somewhere in between conductors and insulators. This discovery led to the invention of the diode, which later led to the transistor. Then many other components were invented that allow us to create many electronics for all kinds of purposes. Later in this session, you will learn more about them. You will see all components available to you and how they work so you can start inventing new prototypes.